Hello students, welcome back to the channel Science Therapy, hosted by the one and only science therapist Abudiwa Sos Ugobela Wemets. And without any further ado, let's look at these questions that we have here. Okay, so we have question 4 still on analytical geometry. This question again here is compatible for both grade 11 and grade 12. So feel free to watch the video all the way up until the end and learn very quick ways to solve your analytical geometry questions. So let's get right down to it. Okay, so question 4 says the diagram below shows the points P0 is to 2 and Q4 is to 0. So these are your intercept. So you have one is a y-intercept and another is an x-intercept respectively. Then point A is the midpoint of PQ. So point A here, we are being told it is the midpoint of PQ, and we can see that PA here is equals to AQ, which actually proves that A there is a midpoint since it is actually bisecting the line PQ. Then line AB is perpendicular to PQ. So line AB, where is line AB? Line AB is perpendicular to PQ, so it meets line PQ at an angle of 90 degrees, right? Then they say PQ and intersect with the x-axis at G, so it also intersect with the x-axis at G and the y-axis at B, right? Okay. Now, interesting. Then 4.1 says show that the gradient of PQ is equals to negative 1 over 2. So this is more like saying calculate the gradient of PQ and find if it's going to be negative 1 over 2. So all we have to do right now is just say gradient of PQ, that's equals to y2 minus y1 over x2 minus x1. Then our y2, if we are using this one as the second coordinate and this one is the first coordinate, then we have 0 minus 2, and then we have 4 minus 0. Then this is negative 2 divided by positive 4, which is obviously negative 1 over 2, right? Then just like that, it's just one mark. Now 4.2 says determine the coordinates of A, which we've been told that they are the midpoint of PQ, right? So that means we use the midpoint formula. So okay, let's just replace the M with the A since we are told that the midpoint is A. Then this is x1 plus x2 over 2, y1 plus y2 over 2. We now have 0 plus 4 divided by 2. So I'm using these ones as the first coordinate and these ones as the second coordinate. Then we are having 2 plus 0 over 2. And then what's the 4 divided by 2? That's equal to 2. Then 2 divided by 2, that's equal to 1. So the coordinates for A are 2 is to 1, right? So just like that, we found that. And then let's keep that. Let's keep that. So we have 2 is to 1 as our coordinates of A. Then 4.3 says determine the equation of line AB, right? Line AB. So obviously, in order for us to determine the equation, we have learned that we need the gradient and a set of coordinates. So we do have a set of coordinates. Those are the coordinates for A, but then we do not have the gradient. But remember, the gradient of PQ, we just proved that it is equal to negative 1 over 2. So if it is negative 1 over 2, and then we are told that AB here is perpendicular to line PQ, then we do know that if we multiply the gradient of AB with the gradient of PQ, then our product needs to be negative 1. Because remember, if the two lines are perpendicular, then we always need to remember that the product of their gradient is equal to negative 1. So how would we then calculate the gradient of AB? We would know that the gradient of AB has to be a reciprocal. So that's -1/2 multiplied by the gradient of AB. So the -1/2 is the gradient of PQ, right? Then equal to -1. So we would have to multiply it by -2 both sides in order to get rid of this -half. So this is gradient of AB is equals to -1 times -2, that's +2, right? So we can see that the gradient of AB is a positive reciprocal of the gradient of PQ, right? So now we do have the gradient, and then we do have a set of coordinates. So what do? We're just going to go y minus y1 is equals to mx minus x1. So that's y minus 1. So we are using the coordinates of A. Then our gradient is 2, and then we have x minus our x coordinate is 2 there. So that's y is equals to 2 times x, that's 2x, 2 times -2, that's -4. Then we transpose the -1, becomes +1. So our equation is y is equals to 2x minus 3, right? But then remember, the -3 here is representing the what? The y-intercept, right? So this will be leading us to the second question. This is representing the y-intercept, which we were told that line AB actually intercepts here on the x-axis. G is the x-intercept, but B here is the y-intercept. So that means that's -3 here is applicable to B here. So the coordinates of B in this case would have to be 0 is to -3, right? Now let's continue. So now they're saying calculate the length of BQ, right? So you see why I hinted to those coordinates there for B being 0 is equals to -3, because we were going to need it to calculate the length of BQ. Now that we have the coordinates of B, to calculate the length, what is length? Length is distance. And then how do we calculate the distance? We calculate it obviously using the distance formula. So that's BQ. So for 4.4, we have BQ is equals to root x2 minus x1, then square, plus y2 minus y1, then square, right? So that means we have our x2. So if we are taking these ones as the first coordinate and these ones here as the second coordinate, then that means we have 4 minus 0, then square that. And then here we have what's y2? Y2 would have to be 0. So 0 minus -3, which is negative, and negative is a positive. So we have that. Now you do not have to do this in a step-by-step manner like that. You can just press all this in a calculator, and then it gives you your solution, right? So if we punch all that into our calculator, we find that the distance is just equal to 5, right? So we have 5. Now, just like that, we have found the length of BQ. And then 4.5 says, show that triangle BPQ is an isosceles triangle. So BPQ, right? So let me just try to highlight that so that we can all see it. So it says, prove that it is an isosceles triangle. Now, what do we know about an isosceles triangle? What we know about an isosceles triangle is that it has two sides that are equal, right? So with an isosceles triangle, we'd obviously have to prove that BP is equal to what? To BQ, right? So if we can prove that this side here and this side here are equal, right, then in that way we could prove that this is actually an isosceles triangle. Now remember, we just calculated BQ, and then we found that BQ is 5 units, right? So for 2 marks, I think we would have to calculate BP. And then BP, looking at where it is much more simple because this is a vertical height. So moving from -3 to +2, the distance in between BP would have to be 5 units, because what does this mean? It would mean that calculating BP, so for 4.5, it would mean that calculating for BP, I would only need to say 2 minus -3. So I take this one up there and then subtract the one here at the bottom. So that's 2 plus 3, which is equals to 5 units. But then now that BQ is equals to BP, so we say therefore our BQ is equals to BP. So this goes to tell us that therefore our triangle BPQ is isosceles. Because of what? Opposite sides of an isosceles, right? And then, okay, so we are done with that. It was just 2 marks. Then 4.6 now is saying if PBQR, so PBQR, again, let's highlight PBQ. So we can see that we don't have R, but they're saying that the R there needs to close this thing off as a rhombus, right? So we need to follow in that order. PBQ, that means the R would have to be somewhere there. So let's try to indicate using a straight line. So obviously it would have to be parallel to this one here, and then the line in here would have to be parallel to the one in there. So this, we can see that it forms that shape, the rhombus, right? But then what do we know about the rhombus? What we know about the rhombus is that the quickest way to just solve here would just to notice that with a rhombus, we have the diagonals being equal, right? So if we are saying that this is a rhombus, then what we know is that our diagonals will have to be equal. So our PQ would have to be equal to BR. That's one thing that we know about a rhombus. The diagonals are equal. So diagonals are equal. But how do we go about and find the coordinates for R? One thing that we also have to note is that if we say the diagonals are equal, that means A there is that point of intersection between these two diagonals. And that means A has to be the midpoint, as we are being told, the midpoint of PQ, but also as well, it has to be the midpoint of ER. Right. Now, this question here is very important because this shows you another use of the midpoint formula. So we are used to using the midpoint formula to find the coordinates of the midpoint. But how do we use the midpoint formula if we do have the coordinates of the midpoint and we are looking for the coordinates that are not the midpoint, right? So remember, we do have the coordinates of B. That was 0 is to -3. We did have the coordinates of A, which we calculated in 4.2. There were 2 is to 1, right? So 2 is to 1. But then now we are looking for the coordinates of R, which we have no clue. Okay, so that means this is how we go about it. If we were to calculate this one, we'd say this is 2 is to 1, and then this is x1 plus x2 over 2, and then it goes to y1 plus y2 over 2. But then now that we do have the coordinates of the midpoint, this is how we go about it. We take this part here, which are the x coordinates, and then we equate them to the x coordinate of the midpoint, right? So this is how we're going to go about it. This is 2x1 plus x2. So I need you to be very careful with this one. And then remember, I do have the y coordinate of the midpoint. So I will take this y coordinate of the midpoint and equate it to the y values here. So that's y1 plus y2 over 2. So what I'm doing is just separating this formula. So I'm taking the x's to the x coordinate of the midpoint. I'm taking the y's to the y coordinate of the midpoint. So now Once I have that, I will say, okay, taking that my x1 will be the coordinates for B and my x2 will be the coordinates for R, then that means this is 0 plus the x coordinate of R over 2. Because I do not have it, then if I cross multiply here, that's 2 times 2 is equals to 4. 0 plus x coordinate of R is x coordinate of R. So the x coordinate of R, I find it as 4. Now I'm going to do it to find the y coordinate as well. So I will say y1 is equals to the y1, again, I take it as the coordinate for B, then plus y of R, which I'm looking for, then this is 2. If I cross multiply here, that's 1 multiplied by 2, that's 2. And then negative 3 plus YR. Now at this point, I need to take the negative 3 over to the side. So this will give me YR is equals to positive 5. Right, so now I can see that I've found my x coordinate and then I've also found my y coordinate. Then writing it in the form of coordinates, I will say the coordinates of R are 4 is 2, 5. So this is very crucial. This is very, very crucial that you understand how to use the midpoint formula, not to get the midpoint this time, but then to find the other coordinates, right? So this is very important, because a lot of time we just know how to find the midpoint, but then how do we use the midpoint to find the other coordinates? That's the question here. Okay, so now with all that being said, I hope you enjoyed the lesson, and then please press the thumbs up button if you really, really enjoyed the lesson. And then if you've been watching the videos and haven't subscribed yet, please, please, please hit that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.